Okay, so the last topic for the foundations of sequences is the topic of recursion or recursion formulas. It's a different way of defining a sequence. So what? It's kind of like recursion means to go around. It's like as a metaphor, a snake biting its own tail. That's what I've heard. Um, and this kind of way of looking at things you will likely see in calculus. If you're in computer science, the idea of recursion comes up a lot, apparently. Um, well, let me give you an idea of what it kind of looks like. I'll work with the most basic example, I think, of a sequence, my favorite, which is the counting numbers. A way a recursion formula would look is you'll get the first term will be given to you. So let's just say we're going to say the first term of the sequence is 1. So first term is 1. And then what you get is a rule or description of how to make the next terms. Um, so let's talk this through. What this rule over here on the right is saying is the term that's going to follow the term before will be found by simply adding 1 to that previous term. So notice there's n plus 1 and n. So this number here on the left will be 1 more than the n here. So what we do is we could say, okay, a sub 1 was given as 1. Sometimes this first term is called a seed term. That's kind of a seed to generate all the other terms. Well, a sub 2, now you just follow the rule that we've laid out here. 2 is bigger by 1, so you would say a sub 2 equals a sub 1 plus 1. The next step would be to substitute. What did we find for a sub 1? Oh, we have it right up here. It is the number 1. You substitute that in and compute. Now the third term, a sub 3, will equal a sub 2 plus 1. Again, observe that the little subscripts are they differ by 1, and this is 1 more than this. It's all kind of laid out there in the rule. And now what you do is say, okay, a sub 2, what was that? Oh yeah, we computed that a minute ago. That's 2. A sub 2 equals 2. So you substitute that in. Now 2 plus 1 is 3. Great. What's the fourth term? Well, a sub 4 is going to equal a sub 3 plus 1. A sub 3 is something we found. A sub 3 equals 3. So you put in 3 in place of a sub 3, compute, and there you go, 4. So the first 4 terms we have found to be 1, 2, 3, 4, and the first 4 terms of the counting number sequence. Now let's try a different example, little more complicated maybe, but not much. Just trying to kind of bring you in here step by step. So remember that the recursive formula will have to give you a first term. So here let's say that the first term is 15, and the rule for generating the other terms will be a sub n plus 1 equals a sub n plus 3. All right, now we go off and write our little list. A sub 1 equals 15, that was given. A sub 2 is going to equal a sub 1 plus 3, that's following the rule that was given up above. Now, a sub 1 we have computed. We computed that in the step before. It is 15. A sub 1 equals 15. We insert that and compute, and we now have 18 as equal to a sub 2. Therefore, a sub 3 is going to equal a sub 2 plus 3. A sub 2 we found in the step above, 18. Substitute that in, and 18 plus 3 is 21. A sub 4. A sub 4 equals a sub 3 plus 3. Now a sub 3 we found in the line above, that's 21. And then we're going to add 3. The adding 3 just came with this rule here. So I believe 24 is the final result. Now, as a sequence, what would our answer look like? Meaning, by a sequence, I just prefer, I think it's better for us to write out the final answer in a line, in a horizontal line. So 15, comma, 18, comma, 21, comma, 24. Okay, let's see. I think, what I'll do is I'll do some worked examples in a separate video to give some variety for recursion formulas. And please let me know if anything's unclear, or you could use more of these videos or whatever. Just let me know. Have a good one.